Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapience Education. For more details of our institution, you can visit our website www.sapienceeducation.com. So today I am going to discuss about the one of the part where of the chapter that is thermal properties of the matter. Okay. So that the topic which I am going to cover is your heat capacity, specific heat capacity, molar heat capacity, and calorimetry and its principle. Okay, so these are the things I want to discuss. Right now, let us go step by step. Now, what is heat capacity and specific heat capacity? Before that, we need to know that what is actually heat. So heat is the form of energy which is exchanged among various body or a system on account of temperature difference is defined as heat. And heat is your transient phenomena, that is flow energy. Okay, for example, this is your body and this is another body. Okay, and it is at a high temperature as well as it is your low temperature. So from body at a high temperature to body at low temperature there will be a heat transfer. As soon as the temperature of both the body will be equal, so no heat transfer will take place, right? So it means that heat is a transient phenomena. We can't say that body has a heat, so it is wrong to say. So we need to always say that there is heat will flow from high temperature to, it is a form of energy which will flow from high temperature to low temperature, right? Now let us consider what is heat capacity. It is the amount of heat required to raise the temperature of a matter by certain amount is called heat capacity. Capacity. Okay, capacity means how much heat capacity, how much heat it can store. Let us consider this as a body. Okay, so I want this body has a mass m and I want to raise its temperature by 5 degree or 6 degree. Okay, so if I want that what is heat capacity, so heat capacity can be defined as the change in heat divided by time t. Okay, or heat, how much heat is required to raise the temperature, how much heat is required to raise the temperature is known as heat capacity. So let us consider, and again I need to clarify this. For example, this is your body. Okay, it has a temperature of it is your 21 degrees Celsius. Okay, let us 21 degrees Celsius. I want to make this body's temperature from 21 to 40 degrees Celsius. Okay, 42 degrees Celsius. So we required heat. So as soon as I am applying a heat, so what will happen? Its temperature will rise. Okay, so the amount of heat required is to raise the temperature is called heat capacity. So heat capacity Q is equal to mass of the body m into specific heat of the body into change in temperature. This is your heat capacity. Okay, understood? So heat capacity is the amount of heat required to raise the temperature of a matter by certain amount is called heat capacity. Now what is specific heat capacity? Specific heat capacity. So heat capacity is especially defined as the ratio of a change in heat or required amount of heat to be raised divided by how much temperature we want to raise. So for example, I applied a heat of 1000 joule, and the temperature difference I have created is among approximately 20. So what is the heat capacity? Heat capacity will be 500 joule per Kelvin, right? So here let us discuss about the specific heat capacity. What is specific heat capacity? When we talk about specific, so you generally divide by mass. Okay, so when you divide heat capacity by mass, so you will get specific heat capacity, and it is denoted by C. So literally, what is the meaning of the specific heat capacity? You need to understand the amount of heat required to increase the temperature by unit mass of a substance through one unit degree. Literally, what is the meaning? For example, you have taken any mass, okay, any substance. So any substance, if you have taken and take the mass of that substance is 1 kg. How much kg? 1 kg. And now Suppose it has a temperature of 28 degrees Celsius. Now change from 28 to 29 degrees Celsius. So for changing from 28 to 29 degrees Celsius, that is change in temperature is only 1 degree Celsius, and the mass of the body is 1 kg. So the amount of heat required to raise the temperature by 1 degree Celsius is known as specific heat capacity. How you will define? The amount of heat required to raise the temperature of unit mass. Always take unit mass of a substance through unit degree, and that is known as specific heat capacity. That is known as specific heat capacity. And specific heat capacity is equal to Q by M into change in temperature. So can we write here Q is equal to MC del T? So if you want to find a Q, that is heat required, so you can use this formula to get the heat required. So I hope you have understood heat capacity and specific heat capacity. Heat capacity is denoted by S and specific heat capacity is denoted by C. Okay, specific heat capacity, when we talk about specific heat capacity, then we are talking about unit mass having unit change in temperature. But when we talk about heat capacity, we don't know how much mass it has, we don't know how much temperature we require. Just we are telling that yeah, we have to raise the temperature by certain amount, and the mass of the body has a certain. So particularly that body has that heat capacity. Okay. But when we talk about specific heat capacity, so it is a basic fundamental of special case of material property. It is your material property. Copper, you take copper of 10 kg, you take copper of 1 kg, you take copper of 0.5 kg. So everywhere specific heat of capacity, specific heat of the copper will be same. But as soon as you will talk about heat capacity, so heat capacity, this body has different, this body has different, this body has different. So heat capacity depends upon mass. Heat capacity depends upon mass, right, as well as depends upon change in temperature. But specific heat capacity does not depend on anything. It is just a material property. So it is your material property. It is your material property, and it is your fix. It does not change at all. Okay. So this is the basic difference between heat capacity as well as specific heat capacity. Now I am talking about molar specific heat capacity. So just now we have talked about mass, but when we come to our molar, so it means that molar, we will talk about molar specific heat capacity. So it is the amount of heat required to for 1 mole of I think it is written 2 times substance to increase its temperature by 1 degree. When 1 kg was there involved, so I have 10 specific heat capacity. But when we talk about 1 mole, so we are considering molar specific heat capacity. Molar specific heat capacity. Okay. So it is denoted by C, and this is also molar heat capacity. You can denote it by mu C and or MC, molar specific heat capacity. Generally we will denote it by MC. So MC is equal to Q by mu into delta T, where mu has been substituted by mass. So what is mu? Mu is the number of moles. You know number of moles? I think everyone has studied number of moles in chemistry. Number of moles is equal to mass given mass divided by molecular mass. So that is the molar specific number of moles. What is the unit? It has a unit of joule per mole per Kelvin. So I hope you have understood this molar specific heat capacity. Okay. Now the very important thing is your calorimetry. What is calorimetry? The branch of physics deal with the measurement of heat is called calorimetry, and the measurement apparatus which uses is known as calorimeter. So here you can see that calorimeter has been insulated from outside. It means that no heat has been lost or no heat has been gained, and the layer has been coated. See here, suppose this is a layer. So in this layer, wool has been filled up. Wool has been filled up, or heat insulator has been filled up. Heat insulator has been filled up. Okay, suppose this is a layer of the box or calorimeter. Now the layer has been made by copper. The layer has been made by copper. Layer has been made by copper. And when this layer has been made by copper, so it means that what it means that it has low specific heat capacity, because it will absorb very less heat, so it does not vary the result. For example, if you have put some water in calorimeter, the heat of the water has been, or energy of the water mostly, if you will absorb by the layer of the lid or tin, so what will happen, layer of the tumbler, so there will be a variation in the reading. So for accurate reading, we use copper lid, so that it will absorb very less amount of heat. Okay, so the device used for measurement of the heat is called calorimeter. I hope you have understood now. Now what is the principle of calorimeter? Okay, principle very important, because most of the numerical will come with this basic principle, right? uh, so principle of calorimeter or law of mixture. See, according to this, when two bodies at a different temperature, let us this consider this is a body 1 and this is a body 2. Okay, this is a body 1 and this is a body 2 are mixed, heat will be transferred from body at a high temperature to body at a low temperature. Let this is high temperature at high and temperature at low. So heat will flow from body 1 to body 2 when we mix it, and they will attain what? They will attain same equal temperature, right? For example, after one will for example, high temperature has 100 degrees Celsius and low temperature has 20 degrees Celsius. So when we mix it, so what will happen? High temperature will reduce. So for example, 100 will come to 80, 70, 60 like this, and the low temperature will increase, that is 20 to 20, 30, 40, 50. So one time will come where both the temperature of both the body will be same. Okay, so what again try to understand here. When two bodies at a different temperature are mixed, heat will be transformed from body at a high temperature to a body at a low temperature till both acquire same temperature. Understood or not? So final temperature of both the body will be same, right? So it means that as per this law, heat lost will be equal to heat gain, right? Heat lost will be equal to heat gain. Okay, so this is heat lost will be equal to heat gain. So this is the principle of calorimetry. Now let us use it. Okay, let us do practical. Let us consider two bodies with a different mass and different temperature. So let us mass of the one body is m1, mass of the specific heat of this body is c1, and temperature is t1. Now the mass of the body 2 is m2, temperature of the other body is t2, and specific heat is t2. As you know that consider this as a high temperature and this is at a low temperature. So there will be heat lost and there will be heat gain. So we know that heat lost will be equal to heat gain. So let us consider heat lost will be how much? m1 c1 into initial temperature was t1 and final temperature is your lower temperature, right? So I have considered, we have assumed that final temperature is TF. Got it? So if we have got final temperature as TF, so finally heat loss will be equal to m1 c1 into change in temperature change in temperature, that is high temperature minus low temperature. High temperature of the higher body 1 is T1 and the low temperature is the final temperature. Now if I am talking about the second body, this second body has gained the heat, and the how much amount it has gained? The Q is equal to, general formula you should understand, Q is equal to MC into change in temperature. So mass of the body is M2, specific heat of the body is C2. Now what is change in temperature? Since here final temperature will be higher because it is at a lower temperature. See, lower temperature will gain the heat, so it will raise its temperature. Higher temperature body will lose the heat. So what will happen? It will lose the temperature, right? So finally, for body 2, final temperature is greater and initial temperature is less. So we have subtract final temperature minus initial temperature. So anyhow we have to make it as a positive. So finally Q gain is equal to Q loss. So finally you will use this equation. So this is a very important equation we have to come to know, right? Okay. So what is the final equation? So this is your M1 C1 into T high temperature minus T final, and this is equal to M2 C2 into T final temperature minus T lower temperature. So this is the very important formula. By using this we can find any specific heat, we can find specific heat of body. So by this method only we have found the specific heat by using calorimeter. See here in calorimeter what we have done. Calorimeter we have an instrument. Okay, so in instrument we have mass of the two body, mass of one liquid, mass of another liquid. So we have got this value. We have got specific heat of the one body, that is you can take as a water. We have got a high temperature, we have got low temperature, we have got final temperature by using the thermometer. So finally the unknown part is your C2. So by using this method only we able to find C2. So this is the method where it has been deployed to find out the specific heat of any of the unknown material. So here what we do, here actually unknown or known material, for example water has been kept and unknown material has been mixed. Okay, and by using the temperature difference we can use the thermometer, and by using this equation we will able to find out the specific heat of any unknown substance. So this is the principle of calorimeter and how to use the calorimeter. And it is not details in class 11, but at least this equation will be used for solving so many numerical at all, right? So I hope you have understood this. If you have any problem, any query, please comment in the comment section, and I'm going to solve mostly numerical in the separate videos at all. So for regular connection of our video, so please subscribe the channel so that you will get regular update of the next chapter. Okay, so thank you for watching my video. Thanks a lot.